Hey, Bear Scammon here at the Eugene Science Center, and today I've got 3 examples of science magic using water today. Now, the first one that I'm going to be showing you today is really cool. It involves a mason jar lid without the centerpiece, and a little screen mesh. And this is just a little plastic one. It's got teeny tiny little holes in it. And what we're going to be doing is we're going to be taking our lid and we're going to be putting the screen mesh over it and screwing it down onto our mason jar. Now what this will do is it'll make it so there's airflow going in and out of the mason jar, and there's plenty of room for water to go through too. You'll see as I pour this water in. That screen has no problem letting that water in. And we can do a little bit of a fun experiment here where if you turn it over, you'll notice that the water doesn't come out. Now, that's not just because my hand is there. You'll see as soon as I take my hand away, the water's actually staying in there just fine. And if I tap the underside, you'll see that it drips just a little bit out. You'll actually see little bubbles of air going up through the mesh into the top of the jar. Now, if I do just a really quick slight turn, you'll see all the water comes tumbling out. Now, the reason that that's happening is these holes have 2 jobs, because there's 2 things happening when I'm pouring water out of this mason jar. One thing that's happening is that gravity is pulling down on that water, telling it to fall out of the jar. The other thing that's happening is that air, the pressure around us, is pushing up and trying to get inside up into the top of the jar to replace the water that's coming out. Now, because these little screen meshes are so small of an area, water and air can't go through there at the same time. Each one of those holes is constantly having this battle where water's being drawn out and air is trying to push in, and they are at a stalemate and they can't make any movements. So long as it's straight up and down, those pressures are equal. But if I turn it just slightly to the side, air has a little bit easier of a time getting in the top, and water's going to get a little bit easier coming out the bottom, and they're going to be able to do that exchange that they really like to do. Now, moving on to our second experiment, it has to do with whether things float or not. And the first thing is I just like to take 2 different objects. I've got a styrofoam ball and a little metal nut, and this is made out of steel, and this is made out of styrofoam. And I've got a little bowl of water, and I just want you to make your own prediction. Do you think the styrofoam ball is going to float or sink? And do you think the metal nut is going to float or sink? All right, let's do the styrofoam ball first. I'm going to do 1, 2, 3, placing it in the water, and we'll see it's floating. And even if I poke it and try and submerge it, it's going to keep popping right back up to the surface. So it's really buoyant is what we call that. It's got a lot of buoyancy force that's pushing it up out of the water. Now this metal nut is much denser, it's much heavier. It's made of a very massive element, iron. And I'm going to drop this in, and you see it just drops right to the bottom. I can try and gently place it in there, and it just does not want to float in the slightest. I'm going to take both of these out. I'm going to talk about another little thing. This is a paper clip. Now this paper clip is also made out of iron, the same stuff that this nut is made out of. It's a lot smaller. So when I drop this in, you'll notice that it in fact sinks. It just sinks right to the bottom. And but there's a special trick you can do to make that paper clip float. So I've taken one of my paper clips and I've bent it an L. I've taken that center piece and I've pried it down so it's a nice flat ledge. Now I'm going to take a second paper clip And I'm gonna put it very carefully on that little ledge that I made. And if I lower it really slowly into the water, you'll notice that it starts to float. And I can do that with a couple of them just to show you. And what's happening here is these aren't special paper clips. They're not made of, I didn't fool you, they are in fact made of metal, but they are light enough and they take up enough area on top of the water that they take advantage of one of water's wonderful properties of surface tension. So you'll see that there's a little divot in the water, almost like it's a little trampoline being pushed down, that's actually holding up the paperclip and preventing it from sinking right through the surface, because these water molecules are holding on to each other and they don't really want to break that bond unless they really have to, like something really big pushes through. So what they're doing is they're just holding it just like a little nest, a little trampoline. All right, and if I poke it, you'll see that these float right to the bottom. All right, so we've got one last experiment, and it has to do with toothpicks. These work a little bit better if you have the flat toothpicks, and then you get some nice Dawn dish soap, and you get a nice large body of water. And it's very important that the bowl or the surface, the sink, whatever you use as your water body, does not already have any soap in it, because if it does, it's not going to work. This only works once. So what I'm going to do is I'm going to take the thickest end, the widest end of my toothpick, and I'm going to fill it up with soap. And once that soap is right on there, I'm going to put it on one end of my bowl here, and we're going to see what happens. 1, 2, 3, dropping it in, and it sails right away. Now, what happened was the soap on the end of the toothpick really wants to mix with that water, and so it'll start spreading out, so it'll jet off. Now, because it's so eagerly pushing off this way, Newton's third law says that for every action, there's an opposite and equal reaction. So if something's pushing this way, it's also pushing the toothpick off that way. So it's a little tiny motorboat. We call it a toothpick motorboat. And I'd love for you to try that at home. Anyway, I'll catch you in the next video. Bye-bye.